So we're still working on the example 1 on 3.6. I've done the first derivative test. I need to do the second derivative test. So I'm going to call that step 5. And this was my first derivative. And I need to do the derivative of that. So my second derivative, I'm going to need the quotient rule. So bottom times the derivative of the top minus top times the derivative of the bottom, which is a chain rule, 2x squared minus 4 times 2x, all over the bottom squared. All right. So I'm going to simplify a little differently on the top than I did with the first derivative, because I have this greatest common factor of x squared minus 4 in both terms, and I also have a 20. I'm going to factor that out. When you factor something out, the greatest common factor goes out in front, and then in the parentheses is where the rest goes. So if I factor that out and factor one of those out, I've got 1x squared minus 4 left. If I factor that out and factor that out, I've got minus x times 2x, or minus 4x squared left. The reason that that works a little bit better than distributing, I'd have to refactor anyway if I distributed, and it would be kind of hard, so this is a quicker way to do it. Within the parentheses, I can combine like terms, so this would actually be 20x squared minus 4, x squared minus 4x squared would be negative 3x squared minus 4. Okay, so there's my second derivative. I square it because I'm going to have to go plug stuff into it, and I have to be ready to find it. So I need my critical numbers. And my critical numbers would be whatever makes the top equal 0 and whatever makes the bottom equal 0. The bottom equals 0 would be plus or minus 2, because 2 squared is 4, 4 minus 4 is 0, 0 to the 4th is 0. Same with negative 2. I'd get those same critical numbers on the top. And I don't believe I'd get any critical numbers from this, because if I set that equal to 0, I'd add 4 to both sides, divide both sides by negative 3, and I'd have to square root a negative value. So that led to no critical numbers. So I've only got 2. Negative 2 and 2. All right, so I got to test my values. I have to pick something between negative infinity and negative 2. Negative 3, got to pick something here, 0, got to pick something here, 3. Now those are my x values that I chose. I'm going to plug them into the second derivative and see what I get. So if I plug in negative 3 in the second derivative, 20 is a positive number. Negative 3 squared would be 9. 9 minus 4, that would be 5, which is a positive number. That would be 9. 9 times negative 3. Negative 27 minus 4, that would be a negative number. On the bottom, I'll always have a positive number because it's to the 4th power. It's an even power. It would make everything positive. So positive times negative divided by positive would be negative. And negative means concave down. Now I'll plug in 0. 20 is a positive number. 0 minus 4 is a negative number. 0 minus 4 is a negative number. For positive, my negatives would cancel, so here I get a positive value, which is up. 3 is going to be the same value as negative 3 because you're squaring 3, squaring 3, squaring 3. It's going to be another negative or down. So if I'm going to summarize my concavity, I would say concave down And that would be, down would be negative infinity to negative 2. And 2 to infinity. Concave up, negative 2 to negative 2 to 2. My possible inflection points are when you change concavity, so negative 2 and 2 are possible inflection points. But if I went back up to the original equation, negative 2 squared minus 4 and 2 squared minus 4 are where it's undefined. They're where I have vertical asymptotes. So there's no inflection points because the possible inflection points ended up being vertical asymptotes instead. So no inflection points. Now I have to take all this information and I need to graph it. So first I had my, let's see, first I had my intercepts. 1, 2, 3. 1, 2, 3. 9 halves is 4 1/2. All right. Next I had my asymptotes. Vertical at negative 2. Horizontal, or yeah, 2 and negative 2. Horizontal was at 2. All right. Then I have my increasing and decreasing and minimums, maximums. I said that 0, 9 halves was a minimum. Well, I already had that marked, and that's a minimum, so it just means my graph will kind of go up like that. All right. And I also had concavity. I had concave down from negative infinity to negative 2. So my graph here has to be concave down, and it also, let's see, it also has to be decreasing. So going down and concave down. And when you have asymptotes, you just kind of want to get close to them but not touch them. Here in the middle, I had decreasing from negative 2 to 0, so that would be down here, and then increasing after up here, so that would be there. Can't touch those vertical asymptotes, so just be careful that you don't. And then last is increasing from 2 to infinity. So here it's going up, and it was supposed to be concave down. So it'll be increasing, but also like a down concavity picture. So there's my sketch.